Today I'm going to be teaching you about thermochemistry. So let's solve this problem first. A gas absorbs 1500 joules of heat energy and expands from 1 liter to 3 liters at a constant pressure of 4 atm. How much work is done by the system? What is the change in the internal energy of the system? So let's just take down some notes. We have here the system, and there's something heat that is going into that system. So that means it is an endothermic process. The gas absorbed is positive. If the system is releasing some energy, then it will be negative, and then it will be exothermic process. So let's exchange the expansion. So if the change in volume is positive, then the work is negative and it is done by the system. If the change in volume is negative and the work is positive, then it is done on the system. So the great demonstration here is just if we applied some force, and it will create compression, and we will have a negative volume which have positive work. So this is the two formulas. There you have it. We all know the internal energy and the work. And actually, work is equals to negative pressure times change in volume. We did put negative P because on the problem, it states that how much work is done by the system. So, by the system, meaning the work is negative. So, we did put a negative sign. So, our pressure is for atmospheric pressure. Just going to plug in things here. So, we can just basically solve this problem. So, let's put 4 atm the brackets, and the change in volume is just 3 minus 1, so the work is going to be negative 4 times 2, and then it's negative 8 liters times atm. So we need to convert this into joules, so we can just plug it in the change in internal formula. So let's try and do that. So negative 8 times L times ATM over 1 multiplied by, there is 101.3 joules of energy into 1 liters times ATM. There you have it. We can just cancel this. And now negative 8 times 101.3 is going to be 810.4 joules. So it does have a negative sign. We're going to put it later. So this is the work. So now we can just plug it into what is the change in the internal energy of the system. So it's internal energy is equals to Q plus W. The gas absorbs is 1500 joules. Going to put it here, and we're going to subtract it into negative 110.4. So we did not put a negative sign on the negative work. So the original equation for chemistry of the internal energy is the internal energy is equals to Q minus W, right? But we did not use it because we already have a negative sign on the work. How much heat energy is absorbed by 70 grams of water if the temperature rises from 25 degrees Celsius to 60 degrees Celsius? So we know this formula. The heat Q is equals to MCAT. So we need to be familiar with this. So Q, it is basically the energy that is absorbed. So here we're going to put it in this one. And this M is the mass in grams. So Q MCAT. So it is easy to memorize, right? Because the delta is just look like a triangle. It can look like a triangle, but in letters it's just A. So it's MCAT. So this C is heat capacity, and this change in T delta T is going to be the change in temperature. So now, what is heat capacity? I'm going to explain it in another video. So we're just going to introduction it here. So heat capacity is basically the amount of heat required to raise the temperature by 1 degree Celsius. So we also have specific heat capacity, which what we're going to use today. So the specific heat capacity of water is 4.184 joules per grams times Celsius. So that means if the heat energy reaches this point, then the degree Celsius will increase, and also the grams will increase. And that's basically it. That's the basic intro for that thing. It is the amount of heat required to raise temperature by 1 degree Celsius. As for the water, it needs 4.184 joules of energy for it to increase in 1 degree Celsius. Now we know the formula and the definitions. So we can just plug it in to Q equals to MCAT. So our mass in grams is 70 times the heat capacity. Water, it is 4.184 joules per grams times Celsius. And the change in temperature, it's going to be 60 minus 25. Then so just multiplying this thing, getting the product of these three, it's going to be around 10,250.8 joules. So this is the energy absorbed by the 70 grams of water. So now let's move on to our next problem. How much heat energy is released when 52 grams of liquid water freezes to ice at 0 degrees Celsius? I literally have a lot of type here. Okay, so we're just going to use this formula, this one. So it does have two. We have two formula here, but we're going to use the kilojoules per mole. Kilojoules per mole. Wow, my vocabulary. So what we're going to do first is find the molar mass of this water. So 1.008, the actual number, but we're going to round it up and round it down. So that 18 grams per mole, that's our M. So that is the M. So it is the molar mass. But we're going to convert it into, but we have it in grams, right? So we're going to convert it into mole. That is what the purpose of calculating the molar mass of H2O. So we can just convert this. So we got 18 grams of H2O per 1 mole. So we can just cancel the grams and the H2O. There's basically an H2O on the mole though. So we got 2.8 repeating mole of H2O. So we can just plug it in here. And now, the heat fusion of water is 6 kilojoules per mole. So the mole will cancel. So in order to visualize that, in here. So getting the product of these two, what do we have? So the energy that is released of the 52 grams of liquid water is 17.3 kilojoules. So that was a lot. The enthalpy of combustion of propane is negative 999. Oh, how to read this? 9990 kilojoules per mole. How much heat energy will be released if 108 grams of propane reacts completely with oxygen gas? So we can just write a chemical reaction here. So propane reacts with oxygen. Of course, it is a combustion reaction, therefore it will release carbon dioxide and water. So we're just going to balance this. We all know to balance this, right? So now it's not balanced. So we have 6 oxygen here and 4 oxygen, and we only have 2 here. So what we need to do is change this into 5. So we will get 10 oxygen on the left and 10 oxygen on right. So now it's balanced. We have 3 carbon, 8 hydrogen, and 10 oxygen. So now we have this. So now it is really unnecessary to do that thing because we can just, because it is not, we're not going to use it here. So it is just an exercise. So now let's calculate the molar mass of the propane. So 3 multiplied by 16, the molar, 12, oxygen is 16, 36 plus 8. So this is going to be 44. So we have 44 grams per mole of propane. Now we're going to use the 108 grams of propane so we can get rid of the grams and we will get the mole, and then we can just use the Q equals to MCAT to calculate the heat energy that is released. So now we got this. Now we can cancel the grams. So we got 2.45 refitting mole for propane. So we can use Q equals to MCAT. Actually, we're not going to use Q equals to MCAT. We're going to use this equation. Why did I say MCAT though? I'm in love with MCAT. So this is going to be 2.45 repeating. And we have negative 999, negative 9,990 kilojoules per mole. Okay, it was hard to read that because there's a lot of 9. Okay, so the energy that is released is negative 24. So we have a negative sign because it was released. So it is an exothermic process. Negative 24,520.9 kilojoules. So that was a lot of energy. The standard heat formation of CH4, carbon dioxide, and water are negative 74.9, negative 393.5, and negative 286 kilojoules per mole, respectively. Calculate the standard enthalpy of combustion for methane, CH4. Okay, so now we all know that this methane, reacts with oxygen, therefore it produces combustion reaction, and it will release carbon dioxide and H2O. So what I did here is just balance the chemical reaction. So what formula we're going to use is this thing. So the standard enthalpy of combustion is going to be the sum of the products minus the sum of the reactants. Not the sum of the products. Right here. It is the standard heat formation of the products and the reactants. Okay, so this is the products and this is the reactants for R and P. So we can just plug in these things. Okay. Let me remove this. So this is going to be 2 water. We have 2 moles of water, right? But we're going to start with carbon dioxide plus 2, and then we have H2O here. So that is the purpose of balancing the equation. We will know how many moles are really there. So CH4 plus 2 oxygen. We have 2 oxygen. So we all know the carbon dioxide. The standard heat formation of carbon dioxide is negative 393.5 kilojoules. And we have 2 multiplied by the water, which is negative 286 kilojoules per mole. And we have the methane, which is negative 74.9, plus we don't have a given of oxygen, so therefore we're just going to cancel it. We're going to consider it as a 0. And now we can just use basic math here. So negative 393.5, we still have this number. And then 2 multiplied by negative 286 is going to be 572. And then we have addition here because negative times negative is going to be positive. And now we can just straight add and subtract these things. So we got negative 890. So I'm gonna 0.6 kilojoules. So that is the standard enthalpy of combustion for methane. So that's the answer. And that's it for this video.